Okay, we're going to go back and do a bit of a review with simplifying radical expressions. Many times you'll get radical expressions like the square root of 23, the square root of 41 that cannot be simplified any further. They're not perfect squares, nor do they have any perfect squares within them. However, in the problems that you see here, all four of them, they have perfect squares that are embedded in them. So square root of 48, there's two ways you can do it. Most students would go immediately to the square root of 4 times the square root of 12. And we'll address that one in a moment. The faster one is to know that 16 times 3, because 16 is a perfect square. So you really need to know your perfect squares. They include 1, which won't help you at all, but they go 1, 4, square root of 4 is 2. 9, square root of 9 is 3, 16, square root of 16 is 4, 25, square root of 25 is 5, and so on. So square root of 16 times the square root of 3 will give you the square root of 48. Square root of 16 is 4, square root of 3. Now that's obviously the fastest way to get your most simplified radical expression. This becomes important in Chapter 2 when you need to rationalize the denominator. Most of the time you don't have to worry about it, but if you do, you need to know how to simplify radical expressions completely. Let's go back to this one. We have the square root of 4, which we know is 2, but then if we think about the square root of 12, it also has a square root of 4 in it, times the square root of 3. Square root of 4 we already know is 2, so 2 times the square root of 3. 2 times 2 is 4, square root of 3. All right, now go ahead and try 54. There's only one way to do 54, and then turn the recording back on once you've done that. Again, you go through your lists of square roots. 54 has the square root of 9 times the square root of 6. Square root of 9 is 3. Square root of 6 doesn't have any other perfect squares, so it's 3 square root of 6. That's the most simplified version. Again, square root of 54 is not completely simplified, so you have to go one more step. Most radicals do not need to be simplified further than the square root of something. All right, let's go over to the square root of 18 and the square root of 72. Again, try these on your own. There'll be only one way to do square root of 18. It's the simpler of the two problems. Square root of 72 actually has two ways, so you might want to look for the easier way first. Okay, on the square root of 18, hopefully you thought through your perfect squares and came up with 9 very quickly. Square root of 9 times the square root of 2. 9 times 2 is 18. Square root of 9 is 3 times the square root of 2. So your most simplified form of the rational expression is 3 square root of 2. Okay, moving back to this number 2, the one that is most common for you to get would be the square root of 9 times the square root of 8. Square root of 9 we know is 3. Square root of 8, though, is not, it can be simplified further because it can be times the square root of 4. There's a perfect square times the square root of 2. Square root of 4 we already know is 2, so 3 times 2 times the square root of 2, which leaves us with 6 square root of 2. That is a little bit longer process, but probably the one you came up with first. If you know your perfect squares, we went up to 25, but the next one after 25 is 36. Square root of 36 is 6. Well, 36 times 2 is 72. You might know that, you might not. This might not be a good way for you, but if you do know it, square root of 36 times 2 is faster. The square root of 36 is 6 times the square root of 2. And there's your answer, 6 square root of 2. All right, hopefully this was helpful for you. I want you to take notes on this recording because we're going to be adding on to this at a later date, just practicing a few more, just to make sure we get this into your long-term memory.